So I was kindly asking you to hold on to your tests and not show them to other people this week, okay? Okay, so if I have, let's say, 3 over x plus 1 equals 5x over 2x minus 3, I state x not equal -1 and x not equal 3/2, and then I cross multiply 5x squared plus 5x equals 6x minus 9. I set it equal to 0, 5x squared minus x plus 9, and I use the quadratic formula.
Okay, that was my mistake.
What is that for?
It was similar to the number 5 problem because
Good.
I made a mistake.
Anything else? We will go over the test. I will post solutions on Wednesday, and we can go over not today, on Wednesday. Yes. I would like to start reviewing for the test. It's a lot to review. Yes, Steph, you had a question?
No,
Yes. Yes, please. Any? So you're talking about this, let's say the square root of,
It's like a long square root of a whole lot of numbers. So then you say multiply by another one.
can you show me what you,
It's from like the third or the second one that we took. You were like multiplying radicals.
oh, I see, I know what you mean. Okay, so let's start with, okay, let's take a look at chapter 10. We want to start reviewing with chapter 10. And I think you're referring to something like this. Problem 60 on page 646. And we have the cube root of 7y multiplied by the cube root of x squared z. Is this something that you had in mind?
Yeah, but it's small.
Okay, we'll find longer ones in a second. So since they are the same cube root, I can write the cube root of 7x squared y z. And before I forget, let me turn my phone off and also look at my final exam schedule, because I took a picture of it, so I don't forget it. Okay, so our final exam is on Wednesday. So final Wednesday next week, which is May the 10th. And I will be in this room starting from, since there is no, bless you, since there is no class before this one, we can start at 2 p.m. 2 p.m. till 4 p.m.
Oh, next Wednesday?
Yes,
Yeah.
final exam. So we meet again on Wednesday. We do not meet on Monday. Okay, Monday's final exams start. That's it. Our last class is on Wednesday. And we meet again on Wednesday from 2 to 4 for the final exam. Okay? Good. So let's look at any questions. Any questions? Any questions? Steph, go ahead. Any questions? Yes.
So, I missed some of the homeworks early in the semester. Am I able to turn them in for a lower
You
grade?
mean paper homework? I can't. I posted solutions.
Okay.
I can do that
What about the IT lab?
by Wednesday. That's the last time.
This Wednesday?
This Wednesday. This Wednesday. You were supposed to turn in everything before each test. Yeah. Okay. So let's not waste time now. So let's work on more problems from chapter 10. What about this equation, which is x equals the square root of x minus 2 and plus 2. This is a radical equation, so let's start solving it. Okay, so any suggestions on what we need to do here? Okay, this is an equation. What can we be asked to do? Excellent. Solve for x. Yes. So let's solve for x. 1 minute.
Subtract 2.
Yes, I have to subtract 2. I completely agree with that. X minus 2.
And we can square both sides.
And then I will square both sides. Very good. So far, so good. Perfect. Next step.
You do want to complete this.
Of course. Next step.
So we write down as x squared minus 4x minus 4
Careful.
plus 4
Correct. Equals.
equals x minus 2.
Very good.
You we're solving for x, you said?
What do you think?
Well, yeah.
Correct. Very good.
So you bring the x over and bring 4. Well, yeah.
I subtract x and I add 2. Any questions? Stop me if you have any questions.
Then you can
And then you can always find the
simplify.
2 and 3.
Oh, you mean factor. Yes, I agree.
Minus 3.
Good. Very good so far.
X equals 2 and 3.
Very good. Excellent. Perfect. Now what? Is it done?
Oh, you have to solve. No, you
I have to. Very good. Thank you. Back in the original problem. 2, does it equal 2 minus 2 plus 2? 3, does it equal 3 minus 2 plus 2? Is the first one correct? Good. So then x equals 2 is acceptable. Is the second one true?
Yes.
Good. So the second one is acceptable too. Very good. Perfect. We want to complete the square. So we are jumping back to chapter 11. Going back, I'm sorry. Moving forward to chapter 11.
So this problem was from chapter 10?
Yep.
Okay.
Yep. We're going to be all over the place. So let's say on page 708, let's look at problem 5. X squared plus 3x plus 1 equals 0. We are asked to complete the square. 1 minute. Don't forget, if you would like to fill out these student opinion forms, they're available till Sunday. Beyond Sunday, you will not have access.
When do we have to share?
Text it to me, email it to me, whatever you want.
I just,
You can show me at the end. Good.
you can do 2 and 3. 2 and 1.
No, because
The question is asking us to use completing the square. So we have to use completing the square, please.
I forgot how to.
The middle coefficient, yes. The middle coefficient, and then we divide it by 2, and then we square the middle coefficient divided by 2, and this is the number we have to add to both sides.
Divide by 2, then square.
Yes.
what was the name of this method?
Completing the square. Completing the square. I'm kindly asking you not to show these tests to anyone this week. Please.
So he said, divide the middle coefficient
By 2 and then square it.
So the next step would be x squared plus 3x plus 9/4 equals 9/4 minus 1. And then the left-hand side is very good, excellent. And the right-hand side is 5/4. And next step, So I complete the square, however, complete the square did not do the job. Perfect. Square root indeed. So then x plus 3/2. What do I write on the right-hand side? Thank you. Plus or minus the square root of 5 over 2. And all I have to do is move 3/2. Negative 3/2 plus or minus the square root of 5 divided by 2. Very good. So name something else that we should look at. Yes, please.
This is chapter 11.
Yes.
Can you do a piecewise?
Yes, absolutely. To graph a piecewise defined function. Excellent. Any questions on this before we graph a piecewise defined function? The piecewise defined functions in chapter 8. Chapter 11, quadratic functions. And solving quadratic equations, chapter 11. Ready for a piecewise defined function? Okay. I'm going to make one up.
One of these.
Yeah. Yep. I made it way more difficult than what we've seen in the past. Why? Why? Because now we know how to graph this and we know how to graph that. Good. How do I start? What is the first step? What do I have to determine first?
Domain.
Excellent. So what is the domain of this function? Please analyze the first interval. What would you say? What is this? What does it represent? In interval notation?
Oh,
So from -1 to infinity,
Very good. Good. What is this?
x is less than -1, but x is greater than -2.
So it's
it's
-2, -1. And this one is
X is less than or equal to
in interval notation. Perfect. Exactly. Perfect. And now I can analyze this and I know the domain of this function. Can anyone tell us the domain of this function? Very good. Well done.
infinity, negative infinity.
Yeah, it happens to be all real numbers. It doesn't have to be, but it is. Good. Which x values must go in the chart?
The square root of x plus 1.
Yes? -2, -1, of course, 0. Good. So now I have to carefully establish which function goes where. So between -infinity and -2, which function will I use? Very good, excellent. Between -2 and -1, which function will I use? Excellent. And finally, between -1 and infinity? Very good. Now the symbols under these two values, under -2 and -1, what are the symbols? Under -2. Under -2. A bracket to the left and a parenthesis to the right. What are the symbols under -1? Parenthesis to the left and bracket to the right. Very good. Well done. So now I have to pick some values. So for x squared, I'm going to pick -3 and -2. So let's plug in -3. What do we get? Excellent. Let's plug in -2. What do we get? Good enough. Does this function open upwards or downwards? Upward. It has a minimum. The leading coefficient is positive. That's how we summarize everything. Now it's everything is one problem. The entire course, almost. Okay, good. So now what type of function is this?
So, it's a,
Linear, very good. Perfect. So let's plug in -2. What do we get?
-2 would be 10, so
5, -5.
Perfect. Let's plug in -1. What do we get?
0.
Perfect. On the other side, let's plug in -1. What do we get?
0.
Very good. Let's plug in 0. What do we get?
1.
And we can also plug in, let's say, 3. And what do we get?
2.
2 indeed. Good. Ready to graph this function?
oh, you get 2.
Plug it in.
The square root of 4 is
Is that okay? Perfect. Okay, so I have -3 comma 9. I have -2 comma 4. Full point or empty point? This one.
That's a full.
Full. And remember, this is a quadratic function opening upward. Next piece.
Wait, how do you know if it opens something will be
It's a bracket. Yeah, it's included. Yep, exactly. Very good. Now the second piece. 2 comma -5. Open or closed? The answer is cannot be closed because at negative, yes. And then -1, 0. Close or open? So -1, 0 is this. And this is a line, and it's done. Finished with that middle piece. Finally, -1, 0. I have to fill it in now. 0 comma 1 and 1, 2, 3 comma 2. Can anyone give us the range of this function?
-5.
2.
What happens at -5?
It's 9.
Very good. The range is indeed -5 to infinity. Perfect. Good. Next type of problem that you can think of.
So how do you know where your arrow is going?
You mean on this one, on this one?
Yeah, when you find the points, how do you know if the arrow will go up or down?
Because this is -infinity. And this is positive infinity. So this is towards that way, where x increases without bound. And this is towards this way, where x decreases without bound. Good? Anything else?
That makes sense.
Any questions? Oh, yeah. What was the difficulty here? Let's talk about the difficulty first before we make up another one.
I just don't remember how to do this, so everything's like.
Okay, very good.
Illustration would be
I'm sorry?
going on.
Okay.
Writing out what's up.
Okay, here it is. Just 2 branches this time, yes. Let's analyze what first. Yes, very good. So can anyone give us the interval notation for the first one?
-infinity to 2.
And the interval notation for the second one, for many reasons.
2.
One is for the domain, and the other one for the bracket parenthesis under that number. Good. So then, what is the domain of this function?
-2, and then no.
Oh, yeah.
All those numbers except for 2, 4.
Negative infinity to 2, union 4 to infinity. Excellent. Good. Good catch. Now, which function I will be using here? Which function I will be using here?
Well, we're going to be using x squared plus 2.
Very good. And here?
Yeah.
Of course. Good. What type of function is x squared plus 2, and which transformations are part of it? I know x squared is this, and then what happens with the graph?
Shifts.
Very good. Okay, so let's find some ordered pairs. So pick some x. I'm going to pick, of course, -1 and 0 for sure. So plug in -1 and tell me what you get.
1
One more time.
plus, oh, 1 plus 2. 3.
Very good. When x is 0,
2.
2. When x is 2,
That's
6.
yes. Very good. Perfect. I'm done with the left-hand side. What about the right-hand side? When x is 4. Perfect. And let's say 8. And also 5. That's good enough. When x is 5.
It's 1.
1.
When x is 8. 2. Very good. So let's graph. So -1, 3. 0, 2. And 2. So that was 3, 4, 5, 6, 6. Is 2, 6 a full point or an empty point? Good. I know that this is a quadratic function opening upward. And it has to stop at that point. Now the other piece, 4, 0, full point. 5, 1, 6, 7, 8, 2. This is the graph of this piecewise defined function whose domain is not all real numbers. Can anyone give us the range of this function?
From 0.
Very good. The range of this function from the lowest possible y value to the largest possible y value. Very good. Very good questions. Okay, x plus 3 divided by x squared plus 5x plus 6 equals 3 divided by 2x plus 4 minus 1 divided by x plus 3. Okay, we're asked to solve the equation, of course, for x. What type of equation is this? Yes, it is a rational equation. Very good. What do I do?
Bring them over to one side.
Yes, if you apply the method that I showed you, which I prefer, but you may not, then you will do that. So I have then x plus 3 over x plus 2 times x plus 3 minus 3 over 2 times x plus 2 plus 1 over x plus 3 equals 0. Several of you forgot to write the equal symbol and 0 when solving this equation, and instead of solving it for x, you just wrote an expression, which was not good enough, right? Because we were asked to solve. Okay, so notice I used the time and the writing efficiently, I think, by immediately factoring the denominator, and then moving both fractions to the other side. I wrote the equal symbol and 0 because there is nothing else left on the other side, on the right-hand side. Next step would be what?
All went together.
Yes, finding the least common denominator, but I would like not to forget something important. Yes, exactly. So I highly recommend write restrictions because you will not forget. You may forget to check, but if you have the restrictions in front of you, chances are that you will not forget. Okay, ready? So what is the least common denominator and the restrictions then? So not -2 and not -3. So this is x plus 2 and x plus 3. I completely agree. And now please give me the adjustments for each. And I did see in one test, someone wrote here, x plus 3 minus 3 plus 1, with absolutely complete disregard of what happens with the numerator.
Wouldn't that be 1?
Yes, for this one is 1. For this one is, oh, I'm sorry. Careful, careful. The least common, I completely forgot. The least common denominator has to have all different factors. 2 is a factor, x plus 2 is a factor, and x plus 3 is a factor. This is the least common denominator, therefore, that needs a 2. Good. Now what about the middle one? Good. And the last one? 2x plus 2, but I'm going to write 2x plus 4. I'm going to already multiply it up there because it's easier. Good. So now can anyone dictate the numerator?
2x plus 6.
Excellent. That's it. What do I do next? Excellent. I have to combine like terms. And I have, this is 4 minus 3, which is x. And this is 10 minus 9, which is positive 1. Am I correct? Over 2, x plus 2, x plus 3 equals 0 over 1. Or you can say a fraction is 0 only when the top is 0. X plus 1 must be 0, x equals -1. And I check here, and I'll say OK.
Quick question.
Yes?
You know the equal sign, so you change that to a subtraction. The initial problem at the equal sign equals x plus 3 over 2.
Yeah, if I have x equals 2, I can write x minus 2 equals 0. That's all I did. So x equals 2 means x minus 2 equals 0. So when I move this term to the other side, I change its sign, and nothing else is left. If I have x equals -2, it really means x plus 2 equals 0. Very good. Okay, let's divide 2 plus I over 1 minus I. How do I divide two complex numbers? So I multiply and divide by
2, -2.
1 plus I. Very good. The denominator is easy because I'm using the formula a plus b times a minus b. What do I have? The numerator I have to distribute. I have no choice. So 2 plus 2i, yes, plus I squared. And the denominator? A plus b times a minus b is a squared minus b squared. What do I need to do next? Very good. You learned a lot this semester. So this is 2. And this is 2 plus 3i minus 1. This is 3i, and this is 2 minus 1. So this is 1 plus 3i over 2. I must separate it. We have to write complex numbers in their appropriate order. So 1/2 plus 3/2 times I. Good. I want to solve the equation 35 on 773. 9 raised to x plus 1 equals 243. What type of equation is this? Very good. It's an exponential equation because the variable is the exponent. Very good. So, what will be my next step here? Grab my calculator and see what this 243 represents. What does 243 represent?
Oh, that's
That says 3 to the
3 to
5th. I think. It's 3 to the 5th.
So 243 is 3 to the 5th? Very good. And then what do I have to do with 9 in that case?
square root 2. So that'd be 2 times x.
So what will 9 represent? 3 squared indeed, raised to x plus 1. I copy the base. What happens to the exponents now?
Multiplied.
Very good. So then it's 2x plus 2 equals 3 to the 5th. From here, what do I conclude? Remember, we are not simplifying anything. We are just thinking. Two numbers are equal and they have the same base. Exactly. 2x plus 2 must equal 5, or 2x will equal 3, so x must equal 3/2. Very good. Well done. I want to graph the function y equals 2 to the x plus 4. What type of function am I graphing? Exponential function. What are the two possibilities? Forget about this for a moment. What are the two possibilities for an exponential function? How can an exponential function look like? This is one option. When the base is, they're all positive. When the base is greater than 1. And what is the other option? Exactly. In other words, decreasing. Not inverse, but I know what you mean. So this is the other option when the base is still a to the x, but this time the base is not greater than 1, but is a tiny positive number between 0 and 1. Knowing that this is an exponential function with a base less than 1 or greater than 1, greater, will it look like somewhat like this or like this? Of course, the first one. However, there is a plus 4. What will that plus 4 do to 2 to the x? What will the... Exactly. So that's the idea. So we already have that in our mind. So then, what is the domain? Because I have to start with the domain of this function. Exactly. It's a friendly function. The exponential functions do not have restrictions. Very good. Excellent. Good. So let's pick some numbers. I'm going to pick, let's say, -2, -1, 0, 1, and 2. These are the regular numbers for an exponential function. Okay. So I'm going to, bless you, I'm going to plug in -2. How much is 2 raised to -2? 1/4. Excellent. 1/4 plus 4. So 1/4 plus 4 over 1 is 16, 17 over 4. So I'm going to say approximate, I'm going to write 17/4, but when I plot, I'm going to plot a little bit more than 4, right?
Below 25.
Yes, 4.25. Perfect. Now let's plug in -1. And I get 1/2 plus 4, 9/2. So that will be a little bit more than, right, 4.5, right, exactly. Now let's plug in 0. What do we get when we plug in 0? Yes, indeed, because 2 to 0 is 1, 1 plus 4 is 5. When I plug in 1,
That's just
when I plug in 2, careful,
no, that's 8.
nice try. Good. So we haven't talked about this, and I'm not going to ask you to remember this, but remember this was 2 to the x, and this is a line that the function 2 to the x will never cross. Since the whole graph shifts up 4, then I know there will be a line that the graph will never cross. Can anyone tell us which line will that be? Exactly.
Okay, that's the constant.
It's a horizontal asymptote. You're going to talk about it in the next course. Yeah. Okay, so -2, -2, 4.25. -1, 4.5. And 0 is 5. And 1 is 6. And here's the graph. It does not touch this line, 2 to the x plus 4. Very good. Let's find the inverse function of x cubed minus 5. I want to find the inverse function. You did not have difficulties with this on the test. Most of you did it very well. Yep, take a moment. I'm putting my attendance in so I don't forget. Okay, so the first step will be to replace f of x by
1.
Very good. Okay, very good. So first step was y equals x cubed minus 5. Next step will be x equals y cubed minus 5. And then x plus 5 equals y cubed. And now I have to take the cube root from both sides. And I only get 1, not plus or minus. That's for the square root. So it's the cube root of x plus 5. So this is our f inverse. F inverse is the cube root of x plus 5. Very good. I'm given 2 functions, and I'm asked to find the function composition. So let's say we have f of x, which is x squared minus 2, and g of x, which is x plus 1. We're asked to find f comp g and g comp f. I saw it in one test. It was completely reversed. F comp g, someone wrote g comp f. And I want to make sure that this is clear. And I want to use synthetic division on this. And then I want to multiply this.
Wait, what? How's this other problems?
Yeah, don't copy them just yet. I'm just copying them because
Oh,
it's easier for me to see them.
alright, I have to get lost for a second.
It's like,
Okay, ready? Let me see with my timer here. Okay, 41. After this, I'll stop it. Okay, so f comma g is f of g of x, which is f of x plus 1. And now I look at f. This and this has to be replaced by x plus 1. So this is x plus 1 squared minus 2. And we've been talking about this for 3 months and a half now. I can say that. So it's x squared plus 2x plus 1 minus 2, which is x squared plus 2x minus 1. If in 3 months and a half you did not memorize this, now you have another week. In okay, now g comma f is g of f of x, which is g of x squared minus 2. And g says g of whatever is whatever plus 1. So it's x squared minus 2 plus 1, which will be x squared minus 1. Synthetic division on this one, please.
Would you simplify that to x, or no, never mind, you said simplify that.
Please don't ask that.
That was,
Take it back.
that was sort of.
Which one did you refer to?
This one. And I didn't understand what Tim was saying, so.
That was